In the early morning hours of February 26, 1991, during a massive sandstorm in the Iraqi desert, a vehicle that the Pentagon's own critics had labeled a death trap drove into military history. It was not the 70-ton M1 Abrams tank leading the spearhead at the Battle of 73 Easting. It was a 28-ton, aluminum-skinned box on tracks. By the time the dust settled, this widely ridiculed machine had destroyed more Iraqi armored vehicles than the heavy tanks it was designed to support. The M2 Bradley fighting vehicle, a machine built by a committee and nearly canceled a dozen times, had just proven that everything the experts thought they knew about armored warfare was wrong. To understand how the Bradley became the backbone of American mechanized infantry, we have to look at the vacuum it was meant to fill. In the 1960s, the U.S. Army relied on the M113 armored personnel carrier. It was essentially a battle taxi, a simple, boxy vehicle made of aluminum that could carry 11 soldiers to the edge of the battlefield. But the M113 had a fatal flaw. It couldn't fight. It was armed with a single .5 caliber machine gun, and its armor was only thick enough to stop small arms fire and shell splinters. If an M113 ran into a Soviet BMP-1, which was armed with a 73mm cannon and anti-tank missiles, the American infantrymen were essentially trapped in a thin-skinned coffin. The Soviet Union's introduction of the BMP-1 in 1966 changed the calculus of land warfare overnight. For the first time, infantry didn't just follow the tanks. They had a vehicle that could keep up with tanks and kill them. The U.S. Army realized they were a decade behind. They needed something they called the MICV-70, the Mechanized Infantry Combat Vehicle for the 1970s. But the road from a 1960s requirement to a 1980s reality was a mess of bureaucratic infighting, shifting requirements, and a ballooning budget that nearly doomed the project before a single production model rolled off the line. The primary tension in the Bradley's development was its identity. The Army couldn't decide what it wanted the vehicle to be. One faction wanted a fast, light scout. Another wanted a heavily armed tank killer. A third insisted it had to carry a full squad of infantry. As these requirements were layered on top of each other, the vehicle grew larger, heavier, and more expensive. FMC Corporation, the lead contractor, found themselves trying to build a jack-of-all-trades that many feared would be a master of none. By the time the prototype was finalized, the Bradley was twice as tall as the M113 and featured a massive turret that took up so much internal space, the infantry squad had to be reduced from 11 men to just 6 or 7. At the center of the controversy was the Bradley's primary armament, the M242 Bushmaster 25mm chain gun. Critics argued that a 25mm round was too small to be effective against modern Soviet tanks and too large for a simple scouting vehicle. But the Bushmaster was a specialized piece of engineering. Unlike a standard gas-operated machine gun, a chain gun uses an external electric motor to drive the action. This makes it incredibly reliable. If a round fails to fire, the motor simply ejects it and feeds the next one. The M242 can fire at a rate of 200 rounds per minute, and its APF-SDS, armor-piercing, fin-stabilized discarding sabir rounds, can penetrate over 30 millimeters of rolled homogeneous armor at a range of 2,000 meters.
But the Army knew the 25mm gun wasn't enough to kill a T-72 main battle tank from the front. To solve this, they added a twin-tube TOW missile launcher to the side of the turret. TOW stands for Tube-Launched, Optically Tracked, Wire-Guided. This weapon changed the Bradley from a support vehicle into a legitimate threat to any tank on the planet. The TOW-2 missile carries a heavy-shaped charge warhead capable of punching through 900 millimeters of steel. This gave a relatively light infantry vehicle the ability to reach out and destroy a heavy tank from nearly 4 kilometers away, long before the tank's own gun was in range. The most heated debate, however, wasn't about the guns, it was about the armor. The Bradley's hull is made of 7017 series aluminum alloy. During the 1980s, a whistleblower named Colonel James Burton alleged that the Army was rigging live-fire tests to hide the fact that the Bradley would vaporize if hit by a standard Soviet RPG or anti-tank missile. Burton's struggle was later dramatized in the film The Pentagon Wars, which portrayed the Bradley as a colossal waste of money. Burton argued that when aluminum armor is hit by a shape charge, it doesn't just hole, it creates a spall effect, spraying molten metal and toxic fumes throughout the interior, killing everyone inside instantly. The Army's response was that the Bradley wasn't supposed to be a tank. It was designed to protect the crew from 14.5mm heavy machine gun fire and 155mm artillery fragments. They argued that if you gave it enough steel armor to stop a tank shell, it would weigh 60 tons and wouldn't be able to carry infantry or keep up with the M1 Abrams. Eventually, after intense congressional pressure, the Army conducted more realistic live-fire tests. The results were mixed, leading to the M2A2 upgrade, which added high-strength steel applique armor plates and a Kevlar spall liner to the interior. This added several tons of weight, but significantly increased the crew's survival. When the Bradley finally deployed for Operation Desert Storm in 1991, it was still under a cloud of suspicion. Many expected it to be a disaster. The vehicle weighed about 30 tons, stood 10 feet tall, and was powered by a 600-horsepower Cummins VTA 903T diesel engine. It had a top speed of 41 miles per hour, which was fast enough to keep pace with the Abrams across the open desert. But the real test would be the Iraqi Republican Guard and their Soviet-made T-72s. During the Battle of 73 Easting, the Bradley's thermal optics proved to be its greatest asset. While the Iraqi tankers were effectively blind in the howling sandstorm and darkness, the Bradley crews could see the heat signatures of Iraqi engines from miles away. The 25mm Bushmaster gun was used to devastating effect against Iraqi BMPs and trucks, while the tow missiles were used to pick off T-72s at long range. In one engagement, a single Bradley destroyed 2 T-72s in rapid succession with its tow launcher, while simultaneously suppressing enemy infantry with its chain gun. By the end of the Gulf War, the statistics were staggering. Only 20 Bradleys were lost in combat, and of those, 17 were destroyed by friendly fire, not by the enemy. The death trap had proven to be remarkably resilient. More importantly, the Bradley was credited with more tank kills than the M1 Abrams during the conflict. This wasn't because the Bradley was a better tank than the Abrams, but because its versatility allowed it to engage a wider variety of targets in more diverse conditions. It could use its optics to scout, its missiles to kill armor, and its chain gun to clear trenches.
Following the success of 1991, the Bradley underwent a series of massive digital upgrades. The M2A3 version, introduced in the late 1990s, turned the vehicle into a rolling computer network. It received an improved Bradley Acquisition System, or IBAS, which allowed the gunner and commander to see the same thermal images on flat panel displays. It also integrated a second-generation forward-looking infrared, or FLIR, sensor, which doubled the detection range of the previous system. This meant the Bradley could now identify a target at 7,000 meters, well beyond the range of almost any weapon that could shoot back at it. However, the 2003 invasion of Iraq and the subsequent insurgency presented a new set of problems. The Bradley was designed for high-intensity maneuver warfare on the plains of Europe or the deserts of Kuwait. It was not designed for urban combat, where an insurgent could pop out of an alleyway and fire an RPG-7 into the vehicle's side or rear. The thin aluminum sides, even with the A2 steel plates, were vulnerable to the improvised explosive devices, IEDs, that became the primary threat in Iraq. To adapt, the Army developed the Bradley Tusk, Tank Urban Survival Kit. This included reactive armor tiles that would explode outward when hit by a sharp charge, neutralizing the jet of molten metal before it could penetrate the hull. They also added a transparent armor gun shield for the commander and a V-shaped hull bottom in some later configurations to deflect IED blasts. But these additions came at a cost. The original Bradley weighed about 25 tons. By the time it was fully up-armored for Iraq, it was pushing 36 tons. This put an immense strain on the engine, transmission, and suspension, reducing its top speed and off-road mobility. Despite the weight gain, the Bradley's performance in Iraq was vital. In the Battle of Najaf in 2004, Bradleys were used as mobile bunkers, providing precision fire support for infantry clearing buildings. The 25mm gun was particularly useful here. Unlike a 120mm tank shell, which might collapse an entire building, the 25mm could be used to put a burst of fire through a single window, neutralizing a sniper without causing massive collateral damage. The vehicle's ability to carry a small squad of dismounted soldiers meant it could drop off troops to clear a house and then stay on the street to provide overwatch. The ammunition for the 25mm Bushmaster also evolved. The M919 APF SDST round uses a depleted uranium penetrator. Depleted uranium is 1.7 times denser than lead and has a unique property. It is pyrophoric. When it strikes primer, the tip of the penetrator literally sharpens itself as it erodes, and the friction causes it to ignite, creating a catastrophic fire inside the target. This round allows the Bradley to reliably penetrate the side and rear armor of even the most modern main battle tanks. For softer targets, the M792 high-explosive incendiary round contains a lethal mix of explosives and a tracer element, effective against unarmored vehicles and infantry. For decades, the Bradley remained a uniquely American solution to the problem of mechanized warfare.
But in 2023, the vehicle faced its most significant challenge yet when the United States began shipping M2A2 ODS, Operation Desert Storm, variants to Ukraine. For the first time, the Bradley would face the Russian army, the very adversary it had been designed to fight 40 years ago. The conflict in Ukraine has provided a wealth of data on how the aging Bradley holds up against modern Russian drones, artillery, and anti-tank guided missiles.
In June 2023, during the early stages of the Ukrainian counteroffensive, footage emerged of a column of Bradleys and Leopard 2 tanks caught in a Russian minefield near Mala Tukmachka. Several Bradleys were disabled by mines and then struck by drones or K-52 attack helicopters. Critics were quick to claim the Bradley was obsolete, but as more footage emerged and crews began to tell their stories, a different narrative formed. While the vehicles were being lost, the crews were surviving. This is a crucial distinction in armored warfare. In Soviet-designed vehicles like the BMP-3 or the T-72, a hit often results in the catastrophic explosion of the ammunition, which is stored in the center of the compartment. This kills everyone on board instantly. The Bradley, however, was designed with survivability as a priority after the Burton controversies of the 80s. The ammunition is stored in armored boxes, and the Kevlar liners prevent fragments from bouncing around the interior. Ukrainian soldiers have repeatedly praised the Bradley for its ability to take a hit from a drone or even a tank shell and allow the crew to bail out and survive. One of the most remarkable incidents of the war occurred in early 2024 near the village of Stepove. 2 Ukrainian Bradleys engaged a Russian T-90M, Russia's most advanced operational tank. On paper, the T-90M should have easily destroyed both Bradleys. It has a 125mm smoothbore gun and sophisticated relict explosive reactive armor. However, the Bradley crews used their 25mm Bushmaster guns to blind the T-90M. By firing a constant stream of armor-piercing and high-explosive rounds at the tank's optics and turret ring, they damaged the T-90 sensors and jammed its turret. The footage from that engagement shows the 25mm rounds impacting the T-90M in rapid succession. While the small rounds couldn't penetrate the tank's thick front armor, the sheer volume of fire caused the tank's reactive armor to detonate and its external systems to fail. The T-90M's crew, blinded and unable to traverse their turret to return fire, eventually lost control of the vehicle and crashed into a tree before being finished off by a drone. This engagement proved that the small 25mm gun, when combined with superior optics and a high rate of fire, can defeat even the most modern main battle tanks through mission-killing their electronics. But the Bradley isn't perfect, and its age is showing. The 600-horsepower engine is struggling to move a vehicle that now weighs nearly 40 tons with all its modern add-ons. The electrical system is also at its limit. Modern tanks and IFVs require massive amounts of power for thermal sights, jammer systems, communication arrays, and active protection systems like Iron Fist, which uses small interceptor rockets to shoot down incoming missiles. The Bradley's 1970s-era alternator and wiring harness simply weren't built for the digital age. This brings us to the present day and the future of the American infantry vehicle. The U.S. Army is currently in the process of selecting a replacement for the Bradley under the XM-30 Mechanized Infantry Combat Vehicle program. The competitors, which include designs from General Dynamics and Rheinmetall, are essentially Super Bradleys. They feature even larger guns, 30mm or 50mm cannons, and are being built from the ground up to support drone integration and hybrid electric engines.
However, replacing the Bradley has proven to be an almost impossible task. The Army has tried and failed 4 times since 1999 to find a successor. The first attempt, the Future Combat Systems, FCS, was canceled after billions of dollars were spent on a design that was deemed too complex and under-armored. The second attempt, the Ground Combat Vehicle, GCV, resulted in a design that would have weighed 84 tons, heavier than an M1 Abrams tank, making it logistically impossible to deploy. Each time a replacement fails, the Army simply goes back to the Bradley and adds another layer of armor or a better thermal sight. This persistence is a testament to the fundamental soundness of the Bradley's original, albeit messy, design. It strikes a balance that is incredibly difficult to achieve. It is small enough to be transported by a C-17 aircraft, but large enough to carry a meaningful number of troops. It is fast enough to maneuver on a modern battlefield, but well armed enough that it cannot be ignored by enemy tanks. It is a generalist in a world where specialists often find themselves out of their element.
The legacy of the Bradley's weaponry is also being felt in the design of the next generation. The Army is moving toward the XM913 50mm chain gun for the Bradley's replacement. This weapon is essentially a scaled-up version of the 25mm Bushmaster. It will have a range of over 4,000 meters and will fire programmable ammunition that can be set to explode above a trench or delay its detonation until it has punched through a wall. This evolution shows that the Army was right about the chain gun concept. They just need more power to deal with modern threats. So why does the US military continue to rely on a vehicle that was once called a death trap? The answer lies in the reality of the battlefield versus the theory of the test range. In a laboratory, aluminum armor might look like a mistake. In a congressional hearing, a 25mm gun might look too small. But in the chaos of a sandstorm in Kuwait or a tree line in eastern Ukraine, the Bradley's combination of reliability, thermal optics, and good enough armor has consistently saved lives and destroyed enemies. There is a specific design philosophy in the US military called graceful degradation. It means that when a system fails or is hit, it doesn't fail all at once. The Bradley embodies this. Even if its TOW launcher is damaged, it still has its 25mm gun. If the gun jams, it still has its armor. If the armor is pierced, the crew has a high chance of escaping. This redundancy is what made the Bradley survive the transition from the Cold War to the War on Terror and now to the high-intensity conflict in Ukraine. One of the more surprising aspects of the Bradley's design that has proven vital in recent years is its swim capability, or rather, the lack thereof. Early Bradleys were equipped with a folding water barrier that allowed them to float and swim across slow-moving rivers. This requirement was a major reason for the original use of lightweight aluminum. However, the system was cumbersome and dangerous. If the water wasn't perfectly calm, the vehicle could easily swamp and sink. Eventually, as the vehicle got heavier with armor upgrades, the swim requirement was abandoned. This was a rare moment of the Army admitting that trying to make a vehicle do everything often means it does nothing well. By removing the swim requirement, the designers were able to focus on what actually mattered: protection and firepower. This decision likely saved the program. If the Army had insisted on a 35-ton floating tank, the Bradley would have likely been canceled in the 1990s. Instead, they accepted that the vehicle would need bridges or ferries to cross deep water, just like the tanks it was supporting. This shift toward pragmatism over wish list requirements is a lesson that military planners are still trying to internalize today.
The cost of the Bradley is another point of data that explains its longevity. In 1980, a Bradley cost about $1.1 million per unit. Adjusted for inflation, that's roughly $4 million today. While that sounds expensive, a modern M1A2 Abrams costs over $9 million, and the proposed replacements for the Bradley are expected to cost upwards of $15 million per vehicle. With over 6,700 Bradleys produced, the economy of scale makes it very difficult for the Pentagon to justify a wholesale replacement when they can simply upgrade an existing hull for a fraction of the cost. The Bradley has also become a victim of its own success in terms of crew comfort, or the lack of it. Because the vehicle was packed with so much equipment, the interior is notoriously cramped. A soldier sitting in the back of a Bradley for a 12-hour mission is subjected to constant noise, vibration, and heat. The engine is located right next to the driver, and the bench seats for the infantry are thin and narrow. Yet, soldiers who have survived IED blasts or RPG hits in a Bradley rarely complain about the legroom. They recognize that the cramped interior is a result of the thick spall liners and reinforced flooring that kept them alive. As we look at the future of armored warfare, the Bradley story offers a counterintuitive lesson. In the 1980s, the critics were technically right. The Bradley was taller than it should be, its armor could be defeated by common weapons, and it was a product of bureaucratic compromise. But in the real world, perfect is the enemy of good enough. The Bradley was good enough to show up in 1991 and dominate. It was good enough to be upgraded for 2003, and it is proving to be good enough to hold the line in 2024. The central question of the Bradley's development was whether you could build a vehicle that protected the infantry while also being a lethal combatant in its own right. The answer turned out to be yes, but only if you were willing to accept a machine that was perpetually in progress. The Bradley was never truly finished. It is a platform that has been in a constant state of evolution for 40 years. This modularity, the ability to bolt on new armor, new sights, and new missiles, is its true secret to success. When the last M2 Bradley is finally towed to a museum, it won't be remembered for the controversies of its birth or the films made about its failures.
It will be remembered for the 25mm chain gun that could blind a tank and the tow missiles that could kill one from 2 miles away. It will be remembered as the vehicle that turned the battle taxi into a battlefield predator. The story of the Bradley reminds us that military technology isn't just about the specs on a datasheet. It's about how those specs translate into the mess and friction of actual combat. A vehicle doesn't have to be perfect to be effective. It just has to be better than the alternative and capable of surviving its own mistakes. The Bradley fighting vehicle was a machine built by a committee, criticized by experts, and doubted by its own government. But for the soldiers who have relied on its aluminum hull to get them through a firelight, it is the most successful mistake the U.S. Army ever made. Looking forward, the lessons of the Bradley are being baked into the XM30 program. The Army is prioritizing an open architecture design, which means the electronics and software can be swapped out as easily as a memory card in a computer. They are also moving away from the jack-of-all-trades mentality by focusing on a 2-man crew and a more modular infantry compartment. But the core DNA of the Bradley, the high-velocity chain gun, the long-range missiles, and the focus on crew survivability will remain the blueprint for American mechanized infantry for the next 50 years.
The Bradley didn't just change how the U.S. Army fights, it changed how the world thinks about infantry. It proved that the foot soldier is not just a passenger on the battlefield, but a component of a high-tech weapon system. The tension between its disastrous development and its stellar combat record is a reminder that in the world of military hardware, the only test that truly matters is the one conducted under fire. And by that metric, the Bradley is one of the most capable machines ever built. As the U.S. military prepares for a future of near-peer conflict, the Bradley remains the benchmark. It is a bridge between the heavy, slow armies of the past and the fast, digital forces of the future. It survived the 20th century, dominated the start of the 21st, and is currently proving its worth on the battlefields of Europe once again. The death trap that wasn't has become the yardstick by which all other infantry fighting vehicles are measured. The final reveal of the Bradley story is that its greatest weakness, its compromise-heavy design, became its greatest strength. By being a little bit of everything, it was able to adapt to every conflict it was thrown into. It survived the desert, the city, and the mud. It outlived its critics and its intended successors. And until the XM30 is ready to take its place, the Bradley will continue to do exactly what it was built to do: carry the fight to the enemy and bring its crew home alive.